This then becomes a SuperSink of pure inertia rather than existential matter. Mother Nature is really, really simple. Everything works off of pressure mediations. So, a supermassive star becomes a black hole when its final fuel becomes iron, and geomagnetic precession initiates a critical threshold of field coherency in the mass, whereby which the mass vanishes from the visible universe. Or as the Greeks would say, the cosmos aesthetos. This then becomes a supersink of pure inertia rather than existential matter.
The sun dies in the same way, but it depolarizes itself down to the zero of its own plane of zero curvature, reproduces itself in the black hole of space on the other. That's all been waiting for it.
Or as the Greeks would say, the cosmos aesthetos. This then becomes a supersink of pure inertia rather than existential matter.
In other words, Einstein says and calculates that an object that's collapsing can't get so dense that it forms a black hole. And he explains in great detail with many equations why this is true, which is as the object gets smaller and smaller, it spins faster and faster, its particles move faster and faster, until its kinetic energy stops decreasing as it contracts. So it reaches a minimum energy condition and it doesn't contract any further.
This then becomes a supersink of pure inertia rather than existential matter. Let's get on to the definition of a black hole here, okay? People forget that the only damn thing that holds up the universe is force divergence due to magnetism. This is the air in the balloon, if you will, of every atom that makes up every existential entity. When acceleration becomes so powerful that it passes the threshold of magnetic divergence, Cartesian existence can no longer exist. Okay? Nobody can this is a quote from Dollard, by the way. Nobody can understand electrical theory without the grasp of counterspace. Counterspace, you want to call it inertia. We have a point where magnetism, force, and motion has been overcome and the threshold is reached due to supermassive and or coherency in being supermassive. Acceleration exceeds force and motion. It is that simple. That is all a black hole is.
Although I totally believe in plasma formations, there are clearly times where there is much more than just electricity and plasma required to explain what we see in space. This is the case in radio galaxy Hercules A. There is clearly actual matter being ejected along the axis of this galaxy from the evidence we see here. I have undertaken hundreds of plasma experiments, and I am convinced that external electricity alone cannot explain the formation we find in Hercules A. So let's take a look at how matter can be ejected by these bowl-shaped magnetic fields. So now I'm going to show you magnetic ejection utilizing the CERN ball. So this one will shoot these magnets, ordinary magnets, about 25 to 30 feet across the room if I have a large room. I don't have that big a room we're working in right now. So I'm just going to show you what I'll do. So pulls it down here, and I'll just put it in through the bottom, through the hole in the bottom. A little tricky. It doesn't really want to go in there. It's kind of against it. But then you get it to where it's a balance point, where it doesn't take any energy. But once you push it past that balance point, knowing that all matter has a magnetic component to it, you can now see how these incredibly strong bowl-shaped magnetic fields in space could accelerate matter to nearly the speed of light without requiring external electricity, black holes, dark matter, or even dark energy.
An eye this perfectly shaped is a real thing of beauty.
The stone, wild and beautiful, dangerous and powerful. There's only one place you can hide that keeps you safe and warm, and that is in the eye of the storm, of the storm, of the storm, of the storm.
This week, Stephen Hawking made worldwide news by saying there are no black holes. Now, I think that Dr. Hawking should be congratulated for his courage in saying that he was wrong. None of us like to say we were wrong. But the news stories have really been significantly off on this subject because they all say Stephen Hawking contradicts the predictions of Einstein's theory of relativity. But that's not really true. 75 years ago, Dr. Einstein proved and published that his theory predicts that there can be no black holes. Now, I'm not talking about whether or not there are black holes. That really is a question for observation. I'll deal with it in a minute. I'm talking about the historical question, does Einstein's theory of relativity actually predict that there are black holes? The answer is clearly no. In October of 1939, Einstein published in the Annals of Mathematics a paper. The paper was about the Schwarzschild singularity. Now, this was before the term black hole was coined, and what they were talking about was the singularity that was in the equations, or the solution to Einstein's equations, developed by Dr. Schwarzschild. So Einstein asked the question. There arises the question whether it is possible to build up a field containing such singularities with the help of actual gravitating masses, or whether such regions do not exist in cases that have physical reality. So what Einstein was asking was, sure, somebody's come up with a solution to my general relativity equations that predict these strange objects, what we now call black holes. But he asked, do they really exist? Is there any way that nature could actually form them? Well, he does some calculations and he concludes, it follows that a particle is bound to follow a path with a radius greater than 2 plus the square root of 3, which is about 3.7 times greater than the radius of the Schwarzschild singularity. In other words, Einstein says and calculates that an object that's collapsing can't get so dense that it forms a black hole. And he explains in great detail with many equations why this is true, which is As the object gets smaller and smaller, it spins faster and faster, its particles move faster and faster, until its kinetic energy stops decreasing as it contracts. So it reaches a minimum energy condition and it doesn't contract any further. So it reaches a minimum energy condition and it doesn't contract any further.
All magnitude, remember, 100% of the visible universe is a Poincaré disk model. If you know what the hell a Poincaré disk model is, it's a model of projective geometry. 100% of the visible universe only exists and is visible because of magnetism. From the atomic scale, from the super micro to the super macro, the air in the balloon, if you will, of the atom, of the earth, of anything else, is comprised only of one thing: force divergence, i.e. magnetism. So, from the micro to the macro, 100% of the visible universe, as far as the air and the balloon, if you will, that is magnetism. If, however, we reach a critical threshold, then the pressure which necessitates volume is overcome, and that critical threshold is reached. The same premise exists in nuclear explosions, whether that be plutonium, uranium. We work off of either critical mass or we work off of implosion, i.e. proximity. Mother Nature is really, really simple. Everything works off of pressure mediations.
Of the telescope, we can just sit at our computers and write these equations, and then we get news headlines. So you've got this strange situation in which there never was any real observational evidence that black holes existed. Science is based on observing nature, not arguing over what nature should be. When scientists looked at quasars and other objects, they certainly saw gravitational contraction. But they never saw any evidence that these were black holes where everything disappeared into. In fact, some of these objects that were very much like quasars but on a smaller scale, called Herbig-Haro objects, clearly were producing ordinary stars at the end of the gravitational contraction. So a star could be at the center of this gravitationally contracting object. Other scientists, including myself, pointed out that other forces, electrical and magnetic forces on a large scale, could produce some of these phenomena as well. So we come to the present day. Is Stephen Hawking the first present-day scientist to say there are no black holes? Well, actually, no. I and many other scientists have been saying this for years. Just this year, a paper with the title "The Impossibility of Gravitational Collapse" by Luganov and Mestrovishvili, who are scientists at the Institute for High Energy Physics in Moscow, published a long paper which not only detailed why relativity does not predict black holes, and in fact forbids it, but also some of the history of the production of the mythology that I just outlined is stated in their paper. So, what's the lesson to be drawn from all this? 75 years of no black holes, and yet 40 years of scientists, producing all of these papers about black holes. I think it says something about the problems that cosmology faces, because too many cosmologists are based purely in mathematics. I mean, you can ask, why could a theory like relativity, which we know has tremendous validity, produce mathematical solutions that don't exist in nature? That's really no mystery. Mathematics is a language that describes what we know about the universe. But just like in English we can describe things that are real, like the chair I'm sitting in, and we can describe things that are not real, like fairies, well, mathematics can equally well describe things that are real and not real. Those of you who remember back to high school or college physics might remember solving quadratic equations, equations that have, x squared in them. Many times these equations, they describe a physical process, they'll have two roots, two solutions. One is positive, that's the real solution, that describes the physical universe, and one's negative. You just throw the other one away, it's not physical. So physicists have to do this all the time. Cosmologists have too often got away from this and simply said, whatever we write down reflects reality. Some years ago, a famous scientist, Hannes Alfvén, who was the pioneer who developed the whole field of plasma physics, wrote that today cosmology is in the hands of scientists who had never visited a laboratory or looked through a telescope. And even if they had, it was below their dignity to get their hands dirty. They looked down on the experimental physicists and the observers, whose only job was to confirm their highbrow conclusions they had reached. And those who were not able to confirm them were thought to be incompetent. Observing astronomers came under heavy pressure from theoreticians. The result was the development of a cosmological establishment, like that of the Ptolemaic orthodoxy, which did not tolerate objections to dissent. So when we think about the saga of the late-lamented black hole, we should also think about what other assumptions of cosmology are also incorrect, some of which I'll go into in a future vlog that illustrates some of what my book says about the Big Bang never happened. Thanks for listening.
Hello class, Professor Anderson here. Let's talk about the gravity that you experience at the center of the Earth. Okay, let's pretend somehow you dug a hole and you got yourself to the center of the Earth and you stood there and you wanted to measure the gravitational force that is acting on you. What do you guys think? What do you think the gravity is at the center of the Earth? Let's say you did this experiment, you dug out a hole, you stood in the middle of that thing, and you said, all right, what do I feel? What do you think? Yeah, Ryan, what do you think? What's the gravity at the center of the Earth?
I don't know an exact number, but it's going to be a lot stronger than the 9.8.
Okay, a lot stronger than 9.8. Why do you think it's going to be a lot stronger than 9.8?
Because your radius isn't going to be like on the crust, it's going to be 0 since you're right in the middle.
Okay, since we know that gravity goes like 1 over r squared, if I go down to r equals 0, it seems like it should go up a lot, right? And in fact, shouldn't it go to like infinity if we're at the center of the Earth? Okay, that's not quite right, because why?
Well, I think like based on the equation you showed us earlier, like r squared was on the bottom, so if that technically is 0, you're going to divide everything by 0.
Right.
So 4 should be 0.
Well, no. If it's dividing by 0, then it's going high, right? It's going to infinity, right? And that is, in fact, what happens if I take all that matter and condense it into a very small point. If I took the entire Earth and condensed it into one point, right? I would need something bigger than the Earth to make this, of course. But let's say I had something that was 10 times the mass of the sun, and I compressed it all into one point. Those do exist in the universe. What are those things called?
Black holes.
Black holes, right? That's a black hole. And the force of gravity increases a whole lot when you get near a black hole.
Because the object is too small to see, at 26,000 light-years away. They would study it by tracking the orbits of stars around it. Even seeing if there is a supermassive black hole at the center of it all, the teams would have to show that it's confined to a very small volume, and that it has enough gravity to whip the stars orbiting it to high speeds. S2 made a dramatic move. S2 suddenly swooped around the center, accelerating to around 3 million kilometers per hour. The American team saw it too. It had come incredibly close to the suspected black hole. If there had been a cluster of stars in there, S2's path and its light would have wobbled. It did not.
But this is a little different, right? Because I, in fact, carved out a little space in there. So I'm not really up against the mass of the Earth. I'm standing in the center of this hole. Any other thoughts on what the gravitational force is if I do that? Any other guesses out there? Come on, let's come up with some wild guesses. Let's go back to this picture for a second. If I'm standing here at the surface of the Earth, what is the force of gravity on me? Thomas, what's the force of gravity on me up there?
Negative G.
Okay. Negative, we draw with an arrow down. It's got a value of G. I have to multiply by my mass, of course. And so it's mg. What about when I'm over here? Austin, what do you think? What's the force there?
mg, then upwards towards the center.
mg upwards. And look, if I'm over here, then it's mg that way. And if I'm over there, then it's mg that way. So Austin, what do you think? What's the force at the center of the Earth?
I would think it would encompass you and cancel each other out.
Exactly right. The force at the center of the Earth is equal to 0. There is no gravity there. There is no gravity there. Specifically, there's no gravitational force. Why is that?
Right? Centipede will be like a drain, right? Pull the drain on your bathtub, things go down the drain like this. And here's, right, this is the null point. Because at the center of gravity, there is no gravity. At the center of magnet, and this is testable, by the way, not my opinion, it's fact. Center of a magnet, there is no magnet. Most powerful magnet in the world, if you go to the center of it, you will find that there is no magnetic flux.
An eye this perfectly shaped is a real thing of beauty.
The stone, wild and beautiful, dangerous and powerful. There's only one place you can hide that keeps you safe and warm, and that is in the eye of the storm, of the storm, of the storm, of the storm.
Hello. This is a question that I've been asked hundreds and hundreds of times because I've got what now is like cult status book on field theory and magnetism, which I never thought it would be. I mean, I've been studying field theory since I was a teenager. Yeah, the fat tattooed guy who translates ancient Greek and Prakrit is an expert in field theory. You know, talk about a subject that isn't going to really make you any money. I never thought that my book on magnetism would be so incredibly popular, but it's usually topics like that don't interest people. Black holes. Now, I've stated many times, showing many different devices, how simplex nature is. Now, Mother Nature doesn't use a calculator. Everything in the universe works off of fields. Fields are not particles, and everything is a field. Everything works off simplex pressure mediation, centrifugal divergence, centripetal convergence. The entire universe is force and motion, inertia and acceleration. Everything is capacitance, resistance, permeability, and permittivity. The explanation, the convoluted explanations for black holes by general relativity and quantum mechanics is so absolutely, incredibly, and insanely absurd that they really strain credulity. I'd have you check, I'll post a couple links below, by a brilliant scientist named Stephen J. Carruthers, who vehemently attacks the insane, endless thousands of contradictions of general relativity and quantum mechanics as far as the definition of a black hole. This is all well and fine, and Stephen J. Carruthers does a supremely good job. And he's an expert mathematician, and he is an expert cosmologist, and he has the math, and he has all the evidences for why relativity and quantum mechanics and their explanations or presumed explanations of black holes are absolutely ludicrous. This is all well and fine, and he does a terrific job of it. But what he never actually tells you is what the hell a black hole is. That's all well and fine to disprove general relativity and quantum mechanics and their insane, harebrained ideas. As Nikola Tesla said, you can think deeply and yet be insane. There are a lot of people in padded rooms and institutions across the world that are very, very deep thinkers, but they're also absolutely crazy and insane. So since I've been asked this question, and this stuff that I'm going to, just some little excerpts from my book, this is all copyright 2016, from my book, Uncovering the Missing Secrets of Magnetism. What is a black hole? Let's get it really simple, because simplicity is divinity, and there is absolutely no greater simplicity, irreducible simplicity, than Mother Nature, for lack of a better term. Okay, I don't really care what you want to call it. So what the hell is a black hole? Math cannot comprehend a black hole because it is non-Cartesian. It has no existential and empirical value. All math is a quantifiable measure, obviously, of magnitudes. And there is where existential math, this is actually where existential math breaks down entirely. We're talking about a non-Cartesian entity. A mass so large, a black hole, in that it has no longer any existential mass or magnitude. Okay, well, this is all well and fine. Okay, let's go on. Let's actually try to define what it is by understanding magnetism. And remember, as I said, everything is force and motion, inertia and acceleration. We're talking about mass and the disappearance of a mass once it reaches a critical point. So, what is a black hole? A black hole is an omni-hyperboloidal in its accelerative nature and is a hypocartesian entity that is a null vectorized point of acceleration. Now, point is still an incorrect term, even though I'm limited by standard English linguistics to call something a point that has absolutely no vector. Quantification is still inaccurate, but these are the limitations of obviously human communication and lexicon. A black hole is a trans-Euclidean entity. It is hypogeometric by its very nature. I will get into what it is and what makes it up and why it must be this way. Hold on, just bear with me. A black hole by definition is that entity at which Mass and magnitude diverge and completely divorce from each other, and this is completely unconventional to common existential comprehension. Anything that has mass is massive, whether that's on the scale of the atomic to this iPad, has magnitude, and therefore partakes of another measure we call time. But as Nikola Tesla and the greatest minds who ever lived, including the ancient Greeks and including the ancient Indians, said, space and time have absolutely no existence whatsoever. These are merely attributional byproducts. Space has no properties, as Nikola Tesla says, so there's no such thing as quantifiable or quantified space. So the notion that a black hole is a hole in space, or that space is something, or that it has properties is absolutely ridiculous, but I'll get into that in a second here. All mass, obviously so, has magnitude, unless the mass and field coherency passes a critical threshold, at which point spatial centrifugal divergence is overcome completely and entirely. Everything is a fight between force and motion and inertia and acceleration. Okay? Everything. All mass. Unless and at which point in time that critical threshold is reached. Just as a critical mass for a nuclear explosion must be reached by either mass or compression, i.e. coherency and proximity, compression initiates coherency in a supermass, namely iron. As stars actually burn up their fuel, they end up producing iron. Ferromagnetism here. Iron is the threshold at which point collapse starts to occur. Why is this? The nature of a cascade occurs in a star when it burns up its fuel, or a supermass burns up its fuel, it starts creating iron, coherency is set up. Once you have coherency, then critical threshold is reached. Namely iron, as I said, and magnitude. All magnitude, remember, 100% of the visible universe is a Poincaré disk model. If you know what the hell a Poincaré disk model is, it's a model of projective geometry. 100% of the visible universe only exists and is visible because of magnetism. From the atomic scale, from the super micro to the super macro, the air in the balloon, if you will, of the atom, of the earth, of anything else, is comprised only of one thing: force divergence, i.e. magnetism. So, from the micro to the macro, 100% of the visible universe, as far as the air and the balloon, if you will, that is magnetism. If, however, we reach a critical threshold, then the pressure which necessitates volume is overcome, and that critical threshold is reached. The same premise exists in nuclear explosions, whether that be plutonium, uranium. We work off of either critical mass or we work off of implosion, i.e. proximity. Mother Nature is really, really simple. Everything works off of pressure mediations. So, a supermassive star becomes a black hole when its final fuel becomes iron, and gyromagnetic precession initiates a critical threshold of field coherency in the mass, whereby which the mass vanishes from the visible universe. Or as the Greeks would say, the cosmos aesthetos. This then becomes a supersink of pure inertia rather than existential matter. Mass has a threshold whereby and when Cartesian magnitude, Cartesian vectors of mass and magnitude and therefore time, but space and time are not things themselves. These are measures. Space nor time has any properties. Tesla said this, the ancient Greeks said this. These are the smartest people on earth. Not that idiot, not that asshole Einstein, not general relativists, who are no different than insane lunatics who are deep thinkers in insane asylums. Not those people, okay? This mass has reached that critical threshold where Cartesian magnitude can no longer exist, and acceleration, inertia and acceleration, force and motion, where acceleration exceeds magnitude, and that threshold drives the appearance or magnitude itself to either be existentially Cartesian or not. Is it over that threshold? A certain point reaches either through coherency or through the mass itself, where Cartesian magnitude can no longer exist. Once a supermassive molten iron core is formed, like in a star, for example, once it's burned up its regular fuel, supermassive, the only thing that defines a magnet, for example, is its field coherency. You know, the neodymium iron boron is exactly the same before it is magnetized, turned into a magnet, as it is after. The quantification of both is exactly 100% identical. The only difference is quality, attributional coherency. The same difference between a light and a laser. Most people don't understand what the hell a magnet is by denotation. There's the same difference between a light and a laser. A pre-magnet versus a magnet. Field coherency. What happens when a star burns off its fuel and is left with iron? Immediately we have a cascade that builds up if the mass is critical enough, such that a threshold is reached whereby which Cartesian magnitude no longer can exist. It drops out of any magnitude. All Cartesian reality, that threshold has been breached, whereby which acceleration dominates force and motion of magnetism. It is literally that simple. This is exactly what a black hole is. It is a point whereby which a critical threshold has been reached where acceleration overcomes magnetism. In the rest of the known universe of all the things we can feel and touch and see, and which have magnitude in space and in time, which have no ultimate reality, these are nothing other than posterior attributes. We have a point where magnetism, force, and motion has been overcome and the threshold is reached due to supermassive and or coherency in being supermassive. Acceleration exceeds force and motion. It is that simple. That is all a black hole is. Let's get on to the definition of a black hole here, okay? People forget that the only damn thing that holds up the universe is force divergence due to magnetism. This is the air in the balloon, if you will, of every atom that makes up every existential entity. When acceleration becomes so powerful that it passes the threshold of magnetic divergence, Cartesian existence can no longer exist. Okay? Nobody can this is a quote from Dollard, by the way. Nobody can understand electrical theory without the grasp of counterspace. Counterspace, you want to call it inertia, you want to call it counterspace. I've called it trans-Euclidean. Actually, science fiction, oddly enough, is kind of had a more appropriate term in their fanciful creation for sci-fi. You know, most things in sci-fi. Oddly enough, the greatest science fiction is the blather that emanates out of the mouths of quote-unquote PhD idiots within the cult of quantum. Oddly enough, there's greater sanity that emits from science fiction sometimes than does from the cult of quantum. Science fiction is called the zero-point energy. I remember one of my favorite TV shows called the zero-point modules for extracting energy out of non-Cartesian subspace. But it's not subspace. I mean, that is completely ludicrous. What it is non-Cartesian ether, whereby which the release of that inertia is a manifestation. Just as Faraday called magnetism the dielectric field of linear, non-Cartesian existence, if you will, is the point by which force and motion and divergence and all energy is made manifest. So let's get on to talking a little bit further in a second video on what a black hole is and wrap things up. Okay? Bye.
The sun dies in the same way, but it depolarizes itself down to the zero of its own plane of zero curvature, reproduces itself in the black hole of space on the other. That's all been waiting for it.
In other words, Einstein says and calculates that an object that's collapsing can't get so dense that it forms a black hole. And he explains in great detail with many equations why this is true, which is, as the object gets smaller and smaller, it spins faster and faster, its particles move faster and faster, until its kinetic energy stops decreasing as it contracts. So it reaches a minimum energy condition and it doesn't contract any further.
This then becomes a supersink of pure inertia rather than existential matter.